Morning, everybody. So I want to talk a little bit today about the types of factoring that we're going to cover in this section of work. We have already started learning about GCF factoring. That's our greatest common factor. We have other types as well that we're going to talk about. Common binomial factoring, which is almost like what it sounds like. A binomial has two terms, so we're going to be looking at common binomial. We have what we call trinomial, so that's when we have three terms. And there are two different types. There's ones where the a value is 1 and a is not 1. We have grouping, splitting the middle term, and then what we call difference of squares. Today we're going to focus on common binomial, which is very similar to GCF factoring. So with that, we're going to get started by thinking about how do we factor 8x minus 4, thinking about what we know about a GCF. Our GCF is 4, and if we factor out a 4, we're going to get 2x minus 1. And as a way to check it, if we distribute back through, 4 times 2x is 8x, and 4 times negative 1 is negative 4. So I know that this is correct. I don't have any other GCFs in the parentheses, so I know that I took out the greatest common factor. Take a look at example number 2 here. Notice how we have a binomial right here, x plus 6, and another binomial on this term, x plus 6. This is what we call a common binomial. It's kind of like a common factor, except for that that factor is a binomial. So this is what we call a common binomial. So I'll just write that down here. When we have a common binomial, we factor it just like as if it were a GCF. So over here, I pulled out my GCF and I put it on the outside of the parentheses. I'm going to do the same thing here. My common factor is a binomial. It's x plus 6. And then what I have left over is 2 plus a. So the 2 comes over here, and the a comes over here. And if I were to distribute that back, I would get what I started with, essentially. So we have our common binomial, the x plus 6 goes over here on the outside of the parentheses, and then we have our 2, and then plus the a. So let's try another example. So again here, if you notice, we have a binomial x minus 2 that is in both terms. So I can factor this out by writing my x minus 2 on the left, and then what goes in the next set of parentheses is an 11 minus b. So the 11 comes over here, and the b comes over here. Thinking about this a little differently, remember how before we were thinking about it as a division operation? If we took that 11 times x minus 2 and our negative b x minus 2, and divided it by our common factor, which is x minus 2, we notice that those cancels out and we have our 11 minus b, which ends up right here in that set of parentheses, just like before. So let's try another. Common binomial, y plus 3 goes on the left in the first set of parentheses, and guess what comes next? It's going to be our 5x and then minus 15. But I want to stop here a minute and I want to take a look at what is in these parentheses, because we should always ask ourselves the question at the end of the problem, do we have another common factor? If I were to look at the y plus 3, there is no GCF there that I could factor out. But if I look at 5x minus 15, I do have a common factor there. I have a common factor of 5 that goes into both the 5x and the negative 15. So I need to factor out a 5 here, which is a GCF in this set of parentheses. It doesn't matter that it's not in here. So I'm going to have this y plus 3. I'm going to put the 5 out front here because it's kind of like a coefficient. And if I factor out a 5 from the 5x, I'm going to get an x. And if I factor out a 5 from the 15, I'm going to get a 3. So we have x minus 3 here. 5 times x is 5x. 5 times negative 3 is negative 15. And now when I look at these binomials, I can see that I don't have anything else that's in common in either set of parentheses. So I'm done with that. So one more example. This one is a little bit different here. Notice how my binomial is not exactly the same. Over here I have x minus y, but over here I have y minus x. If I were thinking about rearranging this a little bit to 32x times x minus y minus 17y, if I move these two terms around, I'm going to have negative x plus y. So let's take a look here. Over here on the left I have an x, but over here on the right I have a negative x. Over here on the left I have a negative y. Over here on the right I have a positive y. So the signs are exactly opposite of the first binomial to the second. So what we can do here in order to do our common binomial factoring, which the binomials have to be exactly the same, I can factor out a negative 1. I can factor out a negative 1 from this set of parentheses. And if I take out a negative 1, that will change the sign here from a negative to a positive. And it will also change the signs in here from negatives to positive and positives to negative. So the sign out here changes and the signs in here change. But now I have exactly the same binomial, x minus y, and so now I can think about factoring this just as I did the others before. So I can put my common binomial, and then I can have my 32x and then plus 17y. And I do not have any more common factors here that I can do between the 32 and the 17, the x's and the y's, so I think that we are finished here. So that is it for now, guys. Have a good day.